Hi guys, welcome to Deep Diver, and in today's video we will be discussing pointers, which is one of the most important and heavily used concepts in Golang. Pointers are not exclusive to Golang, and it is also present in other languages such as C and C++. Pointers have a reputation of being confusing and even scary as a concept. A lot of people struggle with them in the beginning, but trust me, this is a fairly simple concept and it just requires a little bit of patience to master it. In this video, we will build everything step by step with simple and clear examples. By the end of this video, you will have a solid understanding of pointers and you will feel confident working with them. Let me go to my VS Code and create the folders and files required for the coding related with pointers. So I will add a new folder here and we can name it as 9 underscore pointers, and I will also add a new file here. We can also name it as pointers.go. As always, I will have a main package here and also our main function. So now we are ready to start. We will not directly jump into the syntax of pointers, how we can use pointers, etc. Let me build it step by step. So first I will discuss some examples which are necessary to understand pointers better, and then we will talk about pointers after that. So now let me add a statement x colon equal 10. Okay, and here we want to print this value, println value of x. Let us say I have one more statement y colon equal x, and here we are printing value of y. Okay, now let us say to this variable y we are assigning value 200, and we are trying to print here updated value of y, and we also want to check whether the value of x has been updated or not. So I will have one more statement updated value of x, and here will pass x. Let me save this code and open my terminal. So present working directory is this. I will change it to 9 underscore pointers, and now run this code. Go run pointers dot go. So value of x was initially 10, and when we did this on line number 9, the value of y was also 10. When we did y is equal to 200, the value of y got updated to 200, which is our result. But here the value of x is still 10, right? So keep this in mind. We'll be discussing going forward why it happens like that. We will see how memory gets allocated in these cases and why modifying the value of y does not affect the value of x. Now let me discuss one more example. I will introduce a function update, and this function will take an integer as input and it will modify the value of z to, let us say, 2000. Here we'll print the statement modified value, or rather updated value in function update, will pass the variable z here. And now in this main function we'll call this update method and we'll pass this variable y here, and then we'll try to print this value of y after passing to update. Okay, now let me clear this and run this code again. So the first four print statements are the previous code, right? And then we are calling the update function. So this is printing this statement updated value in function update. So you can see We have assigned 2000 to this z, and that is getting printed that the value of z is now 2000. But we pass this y in this update function, but the value of y is still 200, right? Why it happens like that? When we pass a variable to a function, that function modifies that variable, but still here in the main function we are saying the variable is still having the older value. So to understand this better, let us move to iPad and discuss these things there. Let us discuss what happens behind the scenes in terms of memory allocation corresponding to the code we written in VS Code. So what we had there, we had a function main, and first thing we did was x colon equal to 10. So what happens behind the scene in terms of memory location for this statement? First thing is this x will be inferred as an integer, as 10 is an integer. Then as integer takes 4 bytes, 4 bytes of memory will be reserved in RAM. Okay, and the value 10 will be put there, and this memory address can be referenced using this variable x. Let us say the starting memory address of this 4 bytes block is x address. So what is this x address? This is the starting address of this 4 bytes block. Then in our code what we did was we introduced one more variable and we initialize it with x. What will happen again here? So this x is again an integer, so 4 bytes will be allocated in RAM, right? And this x has a value 10, so 10 will be copied here, and let us say this starting address of this 4 bytes is y address, and this memory block can be referenced by y. And then what we did y is equal to 200. So what happens here? So when we do y is equal to 200, the memory location referenced by y will get modified. So initially the memory address corresponding to this y was y address, and here it is 10, and that will be replaced by 200. So here there is no effect on the memory address referenced by x. This statement is only affecting the memory address referenced by variable y. So when we print y here, it will give 200 as the corresponding memory location as 200, but when we print x here, it will give 10 because the corresponding memory location is storing 10 here. Now let us discuss the other scenario related to functions. So we had a function update, right, which was taking as integer input and was modifying this to 2000 and was printing the value z, and here in the main function we were calling this update and passing the variable y here, and finally we are trying to print y here. So what happens here when we call this update of y? So a copy of this variable y will be created first. So what happens, this y is a integer, so again 4 bytes of memory will be allocated in the RAM, and whatever the value is there in y, so currently there is 200, so this 200 will be copied here. Okay, and when the control comes back in this function, this memory address can be referenced using z. Okay, so for now we can name it as z address. Okay, so when we do z is equal to 2000, this 200 will be replaced with 2000, and when we print the value of z, it will print 2000. But when the execution of this function completes and the control reaches back to this print statement, so this y here will not reference this block of memory which was created while calling this update function. This will reference the block of memory which was created initially for this y, and this was this block of memory. So when we do print y here, it will print the value inside this memory which was 200. Okay, and what happens to this block of memory? When this function completes its execution, this block of memory is freed. Okay, and this last statement print y only have access to this. Okay, now let us turn the limitation we have seen above into our requirement. The first thing we want is update the value of x in main function indirectly. What I mean by indirectly here, if you want to update the value, we can do like this, right? X is equal to 10 and then x is equal to 100. But we don't want this. We want to update the value at x indirectly, maybe using some other variable. Okay. And the second requirement is update the value of x through some other function. Okay, so here we don't want to update the value of x in the main function, but through some other function. Okay, so now let us look into the first case, how we can update the value in the main function itself. So let us write function main. Previously we had x colon equal 10, right? So what happens behind the scene in terms of memory location here? We'll have a memory block of 4 bytes reserved. Okay, the value stored at this memory location will be 10, and let us say the starting address of this 4 bytes is x address, and this memory location can be referenced by x. Now we want to update the value of x indirectly, and here comes the pointer into the picture. Okay, so we can do it like this. Let us say y colon equal address of x. So what we are doing here is we are trying to store address of x in y, not the actual value. Okay, so in terms of memory location, it will look like this. First, the Go will try to find the size of this ampersand of x. So it depends on the CPU architecture. If your CPU architecture is 64 bits, this memory location will be 8 bytes. But if your CPU architecture is 32 bits, this ampersand of x size will be 4 bytes. Okay, my system is 64 bit, so let us say this takes 8 bytes, and then this memory block can be referenced using y. What will be the value stored here? So the value stored here will be x address. Why? Because here we are storing address of x, and let us say the starting address of this memory location is y address. Okay, now let us see how we can update the value at x using y. So for that we can write something like this: a star of y is equal to, let us say, 20, and this will update the value at this x here. How? Let us see. So when we say star y is equal to 20, what it does is, so this y gives the x address, right? And this star y tells basically go to the address contained in y and update the value. Okay, so go to the address contained in y. This is the address contained in y. Go to this address which is here and then update the value. So instead of 10, we'll have 20. Okay, let me explain it again. So this star y basically tells go to the address contained in y and then update the value. So the address contained in y is x address. Go to that address go to that address and then update the value. That's why instead of 10, 20 will be written at this memory location. Now if we want to print the value at x, one thing is we can directly print x, and you will see we will run this code in VS Code as well, and you will see it will print 20. And we can also print it like this, star y, and it will also print 20. Okay, so this star y basically again tells go to the address contained in y and then print the value. So it will go to the address contained in y, which is x address. It will go here and then will print the value. Okay, so as in the case of variable, we could have used like this, like when we say print of x, it will give the value stored in x, and when we say x is equal to, let us say 20, it stored the value in x. So similarly this star, which is called dereferencing operator, can be used in the same context. So when we want to print the value, we can say print a star of y, and when we want to update the value, we can say star of y is equal to anything. Okay, so this is our first case. Now let us move into the second case. So for our second case, what we want is we want to update the value of x but through some other function. So let us write code here. Let us say we have our main function, and here we have it initialize again x will 10, and then we want to call some function, and that function should change the value of x. Okay, so we can do it like this. Let us have function update. Okay, and it will take an input of type not int, star int, which is basically saying pointer to an int. Okay, let us call it p, and then what we can do, so for the above case we updated the value using this dereferencing operator. So here we also need to do the same thing. So here we will do star of p is equal to 20. Okay, and how we will call this function from main, we will call this function and pass, what we will pass, x or address of x, address of x, right? So we will pass address of x, and this will update again the value at x. Let me add one more line here, fmt dot println x. Okay, so let us see how it works behind the scene. So for this x colon equal to 10, will have the same story. 4 bytes will be reserved in the memory. It's a starting address, let us say is x address, and this can be referenced using x, and the value here will be 10. And when we call update ampersand x, so what happens is a new variable will be created. And what is the type of the variable? So this is a integer pointer. Okay, this is a integer pointer. It means it contains a memory address which holds a integer type value. Okay, and as we have seen, this memory address is of 8 bytes, so again 8 bytes will be reserved. Okay, and what will be the value stored in this? The value stored will be address of x, so x address basically. Okay, and when the control reaches to this function, this can be referenced using p. Let us say the starting address of this is p address. Okay, so when we do star p is equal to 20, what happens? The same story. It basically tells go to the memory address stored in p. So this is the memory address stored in p. Go to this address and then put the value 20 here. So instead of 10, 20 will be written at this memory address. Okay, so let us add one more print statement here, fmt.println, and here we will write star of p. So what will happen in case of print statement? This star p will behave like a read. So it will say go to the memory address contained in P. So memory address contained in P is X address, and then read the value. So it will read 20. Okay, and when we say here fmt.println x, it will directly read like this. Okay, now let us go to VS Code and try to run this code. So let me get rid of this y. Okay, and as we want to have x only, so as we have discussed on iPad, we'll have a variable like y colon equal address of x. Okay, and let us print here fmt.println, and for x as well, let us print the address println address of x, ampersand of x. So ampersand of x gives the address, and here we'll have address of y is equal to ampersand of y. Okay, and let us not print this address of y. We are interested in fmt.println what is the value contained in y. So value of y. Okay, next thing, as we have discussed, we can update the value at x indirectly through y using the dereferencing operator. So we'll say star y is equal to 20. Okay, and let me add one more print statement here. Value at the address stored in y. So we are trying to print here not the value at the y, but the value at the address stored in y. So we can do that using a star y. Okay, and again here after updating, you can print updated value at the address stored in y. Okay, so we'll say here star y, and now let us try to run this code. So let me clear this. If I say go run pointers.go, so first thing we have the address of x. Okay, and then the value of x, which is 10, which is expected, and then the value of y, you will see it is same as the address of x. Okay, so this confirms that value of y currently has the address of x. Then we are printing value at the address stored in y using this star y, right? So here it is printing 10, and then we are putting the value 20 here using a star y. So the value gets updated at the address stored in y, and now the value has become 20. We have seen on the iPad how it works internally. Now I am just showing you the code. Now let us write the code for the second case as well. So here I will comment it out, and let me introduce a function. So I will use the same update function, but here instead of int, let us use integer pointer, and now it is giving error because we cannot update it like this. We can update using dereferencing operator. So star z is equal to 2000, and here we'll print updated value in function update using star z, and here we need to call this function. The function name is update, right? And what do we need to pass here? The address of x, correct? Now we'll again print updated value of x. This time we'll use x here. Okay, and let us print one more thing, fmt.println value at z. Okay, what the z contains, it stores the memory address of x. So if I run this code again, let me clear and run this again. You will see address of x is this, value of x is 10, all right, and then value at the z is this, which is same as this address of x. So what the z contains here? Z contains the address of x, and then we update the value at line number 6. So we'll have updated value in function update 2000, as well as updated value in this main function is also 2000. So now we have fulfilled both our requirements. One was updating the value of x in the main function, and the other was updating the value of x through some other function. Now let us discuss why we are modifying the value of x like this. What was the need of pointer at first place? Right. Here we could have just said x is equal to 50, right? And it would have updated the value at x. But we have a requirement that here this update function is very straightforward, and here we are just assigning the value. But let us say this update function was doing a complex calculation, and then we wanted to update the value of x. Then we can't do inside this main function, right? We'll have to pass this x like this, and then we can do the complex calculation here, and then we can update the value at z. Okay, so this is one requirement. So why we need pointers? First one is modify the original value across functions. Now let us say, as we have seen in case of arrays, we had a function modify array there, and we were doing some modification on the array, but the modification was not reflecting on the array created in the main function. So let us try to create the same example in pointers here as well. So let us say we create an array, this time of size 3 only, and we initialize values at 10, 20, 30. Okay, and then we have a function update array where we are passing this array, and then we will write this update array function. Update array, it takes a array of size 3, and now here we update the 0th index with value 100, first index with value 200. Okay, here it is giving error. Let us remove this extra comma, and now fmt.println array in update array. Here we'll pass this array, and in the main function as well we'll write one more statement, fmt.println array in main. Okay, and here we'll write like this, go run pointers.go. So here you will see we have created an array with elements 10, 20 and 30. We pass that array to update array, and here it was trying to modify the array. So array in update array was modified, and we have 100 and 200 and 30 which is expected, but array in main is not getting modified. So what happens is, when we pass this update array like this, it creates a copy of this. So let us go back to iPad and discuss this thing as well. Okay, so what we are doing in main, we are creating an array of size 3. Elements will be int and value 10, 20, 30. Then we have a update array function, and we are passing this array here, and then we are printing array, and we have our update function here, update array, which takes as input array of size 3 basically, and then here we are trying to change the value at index 0, 100, and at index 1 we want to put 200. Okay, and here also we'll print this array. So here it was printing 100, 200, 30, but here it was printing 10, 20, 30. So what was happening behind the scene? So for this first statement, what happens is a variable array will be created, okay, and corresponding to this array of size 3, will have memory allocated in the RAM. So as the array size is 3 blocks of 4 bytes each. Okay, so 4 bytes, 4 bytes, 4 bytes, total 12 bytes, right? And the value will be 10, 20, 30 here. Okay, now when this update array function is called, what happens is Go will create a copy of this. Okay, so in RAM it will again create a copy of this with the value 10, 20 and 30, and this will get passed to this function. So when inside this function this first statement is executed, instead of this 10 will have 100, and instead of this 20 for this second statement will have 200. So when we print this array in this update array function, we'll have 100, 200 and then 30. Okay, but when the control comes back and it tries to print the array, this array is pointing to this. Okay, so this will print 10, 20, 30. Okay, so what is the issue here? To pass the array to this function, the entire copy is being created. So here the size of the array was 3, so only 12 bytes was allocated again. But what if this array was of size 10 to the power 5? Then again 10 to the power 5 into 4 bytes array size will be allocated, right? And also we are facing this difficulty that we are trying to modify the original array, but we are not successful in doing so. Okay, to solve this problem as well, we use pointers. So what we do here, so instead of passing array here, we pass address of array, and instead of expecting the array here, we expect a pointer to that array. Okay, and then we can update the function like this. So now let us go back to VS Code and write the code for this. So this is our VS Code. So here what we need to change, instead of passing the array, we need to pass the address of array, right? And in this update array function, instead of expecting array, we need to expect a pointer to an array. Okay, let me run this code again. So here the output is array in update ampersand and then the values 100, 200 and 30. Okay, as this arr is pointer to an array, that's why it is printing ampersand at the beginning as well. Now in array in main, you can see is printing 100, 200 and 30. So we were able to modify the original array when we pass the address of the array instead of the whole array. So how this works is, let me go to the iPad and then complete this. So let me delete this one. Okay, let us discuss what happens when we are passing address of array. So when we are passing an address of array, the memory block will be reserved, but this time for 8 bytes only, as addresses can be 8 bytes long, and inside this we'll have the starting address of this array. Let us call it array start. Okay, so we'll have array start here, and when the control comes back to this array basically has this data. It has a address array start, and when we try to execute this first statement, what the Go does, it goes to the memory location stored here and then updates the element. So instead of 10 we'll have 100. Similarly for this second statement, array1 is equal to 200. As this is not very clear, let me create a bigger box. Here we'll have array start. Okay, and this is pointing here. Okay, so for this second statement, what happens is it will go to the memory location stored in this array, so basically here, and then it will update the first index. So here instead of 20 we'll have 200. So this is how it works internally. Okay, now let me go back to VS Code. So we can write one more reason of why do we need pointers: to avoid copying of large data, as we have seen this in case of array. Right, now let me tell you one last thing. This is the code. I will uncomment these 4 lines and let us try to declare a pointer in different way. So here we can use where keyword. We'll give the pointer name, it is again y, and then pointer to an integer. Okay, and then we can initialize it like this, address of x, and it will just work fine. So if I clear this and run this code again, go run pointers.go. So this is working fine as well. So this is one more way by which you can declare pointer. And let us say here, instead of initializing the y at its declaration, we do it something like this. Then what do you think before this assignment, what the value of this y will be? So let me print value of y before assignment y. So here you can see value of y before assignment is nil. So when we use this where keyword to declare a pointer and we do not initialize it with any value, then that pointer contains a nil value. Okay, this is it for this video. I hope I was able to explain pointer. See you in the next video.